In the late 1800s, the world was undergoing massive change. Electricity was lighting up cities, telegraphs connected continents, and the Industrial Revolution was in full swing. But deep within the heart of matter, a silent mystery remained. People believed the atom, the smallest unit of matter, was indivisible, a solid sphere, the end of the line. But Joseph John Thomson, a British physicist born in 1856 in Manchester, was about to shatter that belief forever. Man scientist, a curious mind. J.J. Thomson wasn't a flashy scientist. He was soft-spoken, thoughtful, and intensely curious. As a professor at Cambridge University, he worked at the famous Cavendish Laboratory, a place known for groundbreaking discoveries. He didn't look like someone who would change physics, but he had something more powerful than appearance, a relentless desire to understand the invisible. At the time, scientists were experimenting with cathode ray tubes, glass tubes where electric currents passed through gases. Strange greenish rays would appear inside. What were they made of? Some thought the rays were waves, others believed they were just a trick of light. But Thomson believed they were particles, something real and incredibly small. High voltage, the discovery of the electron, 1897. In 1897, through a series of careful experiments with cathode ray tubes, Thomson discovered that these mysterious rays were made of tiny, negatively charged particles. They moved with speed, had mass, and bent in electric and magnetic fields. He had just discovered something smaller than the atom, something inside it. He called them corpuscles, but we now know them as electrons. This was a scientific earthquake. For the first time in history, someone had broken open the atom and found something inside. The atom wasn't solid and indivisible, it had parts. Pie the plum pudding model. Now that he'd discovered electrons, Thomson had to figure out where they fit inside the atom. In 1904, he proposed the plum pudding model. Imagine a pudding or cake soft and round with tiny plums or raisins scattered inside. In this model, the atom was a positively charged dough, and the electrons were embedded within it like chocolate chips in a cookie or raisins in a pudding. It was simple, it was elegant, and although we later discovered it wasn't quite right, it was the first atomic model to include internal structure. Trophy, a legacy etched in science. Thomson's work opened the door to modern atomic theory. Thanks to him, scientists like Ernest Rutherford and Niels Bohr went even further, leading to the discovery of protons, neutrons, and the nucleus of the atom. In 1906, J.J. Thomson won the Nobel Prize in Physics